Hi, Assalamualaikum. My name is Tazha Nadia Binti Ishak, and I'm from Section 4, Group 12. And I'm going to present about earthwork, and our company's name is Bermuda Construction Sendirian Berhad. So in this video, I will talk about project description and proposed level, grid method, and also cross section, and the last one is slope stability. So for the project descriptions, generally the approximate locations of the project site, which is at Zone B, located at Kangapulai, Johor Bahru, as to compare to the destination from the Johor Bahru town, it take about 17 kilometers, and from the UTM take about 4 kilometers to the proper site. We found out that Second Link Expressway, which is leading to Tuas, Singapore, covers up to approximately 4 kilometers. So for the site inventory, because of the MCO, we can't enter the site area, so we take another alternative by using Google Earth, where we search the image of the area, and so that we know how the area looks like. So the total area is 70183 meters square, and the terrain is hilly. The existing building is we got residential area at the left side of the project, and the exit stream is Pulai River, where the flow is from south to north. And because of the area is palm oil plantation, so the soil type is peat soil, and the highest point is 47.45 meter, and the lowest point is 24.62 meter. And at the same time, we found out the existing structure at the area is culvert, earth drained, and concrete bridge. So for the record, there's no highest flood level we found, and the climate as we live in Malaysia, it's always wet and dry throughout season. And for the existing utilities, we found out the water pipelines and also TNB transmission line. From the topo maps, we found out our highest point and also our lowest point. Our highest point is 47.45 meter, where it is located at the top of the area, and for the lowest point is 24.62 meter, where located at the bottom area, as you can see at the picture. So for the proposed level, we estimate the proposed level by try and error method, and we considering all the elements such as existing drainage flow, existing road level, and natural drainage. So as you can see here, we got different colors. Different colors shows different proposed level. So the light green at the top of the side is 34 meter, and the dark yellow is 37 meter. For the light yellow is 38 meter. For dark brown is 29 meter. For the dark pink is 26 meter. For brown is 28 meter, and the light pink is 25 meter. So we decide this proposed level, and our limit is not over than 5 meter between the proposed level. So this is how it looks like. Alright, we move to the next, which is grid method. So we decide to put the dimension of our grid is 25 times 25 each grid. So how we do this grid method is because we want to find the cut and fill volume. So each grid, the area we times with 25 times 25, and we got 625 meters square. And for example, we take out one grid where the dimension is 25 times 25, and then we take the proposed level, and we take every corner, the height of every corner. We got four corners at each grid. We take the nearest height at every corner. So when we got the then we average, we divide it by 4, and we take an average, and then we get the difference of the height between the existing ground level and also proposed level, and we got 6.8. And for the volume of cut, we multiply it by the area. So 6.808 times with 625 meters squared, and we got 2127.343 meter cube, which is cut. Next, we do the same thing as other grids where it will cover the whole proposed area. So this is the final cut and volume. So the total cut volume is 416,156.42 meter cube. We times with 120%, and we got 502,987.7 meter cube. So the total fill volume, we got negative 434,629.71 meter cube. So the percentage difference between those two we calculate as volume of cut minus with volume of fill, and divided by average cut and fill volume, and we times with 100%, and we got 6.65%, which is less than 50%, and it is suitable and okay for our volume, for both our volume. After we determine the cut and fill volume, then we make a layout, and we color it by yellow and blue. For cut area, we will color it as yellow, and the fill area we will color it as blue. So as you can see here, almost the highest level of the area we will cut it, and the lowest area we will fill it. Next, we will talk about cross-section method. So based on the zone B, our proposed site, we have 5 horizontal cross-section and 2 vertical cross-section, where this cross-section will cover the whole area, and it will shows how the cut and fill looks like. So I take one example. So as you can see in this example, the proposed level is 25, and the existing ground level we got it from the table we did earlier, and then the solid line over here is our proposed level, and our another line is existing ground level, and at the left side of my picture, there shows a cut area, and the right side of my pictures, it shows the fill area. This is cross section EE. So while doing this, we set the scale for the vertical scale. The ratio is 1 to 0.2, and for the horizontal scale, the ratio is 1 to 25 according to the grid size. The last point is slope stability. In order to find out the slope stability, we use Bishop method. We adjust the slope stability, and we calculate as in the table, and we compare it with the FOS. If our value is more than FOS, so it is suitable. So the slope stability is suitable for our site. Alright, that's all from me. Thank you.